we come to the more practical sense of how to use logistic regression, and not all logistic regression models are used only with numeric features. Of course, we'll have categorical features, and we know a very good way of handling categorical features, which is by using dummy variables, as we saw in our linear regression. So logistic regression can still be used with categorical features. Let's see what this looks like. We come up with a high underscore BA column, which is nothing but the BA column of the glass data set to 1 if that value is greater than 0.5 and 0 if it is not. Now let's see how Seaborn draws this logistic curve. So on the x-axis, I have the BA values, and on the y-axis, I have the household values. Now, this is a continuous feature. BA is a continuous feature. What about high BA, our newly hand-coded categorical feature? This is how it looks like. So we see that we have values on either side of the quadrant on the far ends, and the curve just goes through. If we just introduce some jitter on our data, then we get something like this. And notice how we can easily interpret this model. So having a high BA interprets to be increase in the probability of household, since higher the BA, the more values of household equal to 1 is being observed on my data set. Now, in order to fit a logistic regression model to a categorical variable, all I have to do is choose that as my feature column and fit a logistic regression X and Y. Now, in this case, we get a coefficient of 4.42 for high BA. So the interpretation in this case will be having a high BA value is associated with a 4.43 unit increase in the log odds of household as compared to a low BA value. Now, for dealing with more heavier categorical features, I recommend you use the getDummies function in pandas to come up with the categorical features and then use them as the X columns, and then interpret how each of those columns and their coefficients affect the response.